Welcome to Commsverse. This session is called Local Media Optimization with anynode SBC, and today we're presented to you by Tobias Eriksson.
Good morning, everyone. Welcome to the online Commsverse 2020. And I'm really excited to be presenting this session on behalf of T-Systems. After a short introduction, I will be highlighting the various ways in which media handling can be achieved between the anynode session border controller and the Microsoft Teams infrastructure. If you have any questions, please post them in the chat window and we will answer them at the end of the session. Okay, short introduction. My name is Tobias Eriksson. I've been using telecommunications since my early senior high school years with analog modems and ISDN cards and doing stuff like Usenet over UCP. That was still at a time when the internet and it's always on was only available for large enterprises or universities. I'm also the founder and CTO of T-Systems. T-Systems is a privately held company which is located in Germany. We develop communication software for close to 30 years now. We started with ISDN when that was deployed in Germany and have always been focused on telephony and fax solutions. We were actually implementing unified communications at a time when the term has not yet been invented. For a little less than 20 years now, we have moved into voice over IP communication. Since the mid-2000s, our middleware XCAPI has been the go-to solution to migrate a host of different UC Windows applications from the ISDN world towards voice over IP. From that development, we gained a lot of expertise in voice over IP protocols. When we needed to adapt the XCAPI to various PBXs and voice over IP carriers, and that has been really instrumental in developing our new flagship product, anynode. But more about that in a short moment. For some time now, we have also established a subsidiary in the United States, and that US branch helps us to accommodate customers, especially in Northern America. Yeah, now this session is about anynode, which is a session border controller. And I would like to, get everyone together. Perhaps there are some people who are not that deep into the subject, so I want to talk a little about that. The session border controller is intended to control all signaling and media streams at the border of your network. And anynode will handle quite a few tasks in this area for you to have an optimal solution. It will assure interoperability between SIP systems that would, for various reasons, not be interoperable with each other. That might be different implementations or interpretations of the various ZIP RFCs, or it might just be simple things like one end using IP version 4, the other using IP version 6. Or even simpler, sometimes the format of zip addresses may differ between different parts of your VoIP infrastructure, and anynode can adapt those to match each other. One important thing is that a session border controller will act as a back-to-back user agent. It will not be a zip proxy or something like that, which will just change various parts of your signaling and forward it, but it will terminate the signaling session, and it needs to understand each of the information elements, and it will not forward that information to the other side for security reasons. On the media layer, the SBC makes sure that the media data can traverse your network boundary without being impaired by firewall or different net implementations. In case of incompatible codecs, anyone can transcode between those various formats and make media interoperability possible. There are various other ways in which an SBC can be used to facilitate various aspects of voice over IP communication, but that would be a topic of another track. And so we will really focus on the media side of VoIP communication, and that especially in the area of Microsoft Teams direct routing. Yeah, just for a short clarification, we will be talking only about Microsoft Teams direct routing. This track is not about other possibilities. So it's only how to add via an SBC external voice over IP infrastructure. Anynode has been certified to be used with the direct routing mode of Microsoft Teams. And that makes sure that you get a successful interoperability between your various external devices like PBXs, devices, and voice over IP providers together with your Microsoft Teams environment. The ultimate goal when interconnecting various voice over IP peers is to have a high quality media exchange. All intermediate entities are only there to achieve that goal and to have a person to have a really high quality audio conversation. Voice over IP within the local network is in most cases a done deal. The admins should have the local network in their control, but there are still two other components that can interfere. One is the network boundary with its firewall net implementations. And of course, those components are essential to create network security for your company to separate the internal and the external network. But sometimes there can be the biggest obstacle in establishing two-way audio connections between those network boundaries. To mitigate those obstacles, various solutions and protocols have been created in the past years to allow reliable audio communication even in those scenarios. The second problematic component is, of course, the external network with its quality characteristics like packet loss, latency, jitter, and stuff like that. Anynode's SBC functionality, together with its support of the various Microsoft direct routing media models, will help you to achieve the best media quality possible. When Teams direct routing was originally announced, the base mode of operation was something that was called non-media bypass. Protocol-wise, that was the most simplest implementation, but also the one with the biggest drawbacks. All media exchange between the peers would have to go through a centralized component, which is the Teams phone system in the Azure cloud. In this graph, you will see the audio flow for Teams clients which are internal of the company's network, where even the media data will flow to the Microsoft cloud, also from external Teams clients, and then all this data is fed back through the external network towards anynode, which then will terminate it with the voice over IP provider. That's the most basic way that you can configure the Microsoft Teams direct routing. But the disadvantage is that the media data always takes what I would call the long road, which can cause higher latency or, depending on the network connectivity, jitter or even packet loss. So we now see a slightly improved version of MediaFlow that was introduced by Microsoft, which is the media bypass. And in that area, the media may take the shortest path possible. If you have external clients, the RTP media data doesn't go to the cloud anymore, but it can directly communicate with the anynode SBC, and then it is forwarded to the VoIP provider. The same with internal clients, but here on media bypass, the media still has to go out of the network and then back into the network again. And The protocols that are used to do that, it's called ICE, and especially in the direct routing environment, a subset of that is used, which is called ICE Lite, where only a subset of candidates can be used to negotiate which media path the various peers are going to be using to connect the media to each other. But already in this scenario, in lots of cases, you will have a very much shorter communication path of the media packets, because not everything needs to go to the Microsoft Cloud and then back again, but whenever possible, shorter paths are used. Well, fast forward a little while, and Microsoft has now announced local media optimization for some time, and anynode has embraced that. And in that scenario, the highest level of media path control is available. And we start this by using a simple example. In the prior slide, we had the same scenario, but with just standard media bypass. And we're now using the local media optimization to even improve that scenario a little more. In the former scenario, the data from the internal client needed to go outside of the network and then in again. In this scenario, we have the ability to have an internal media port, and the Teams client, which is in the internal network, can directly connect to anynode without going over any net or firewall things. So the signaling from Microsoft will inform the anynode SBC whether the Teams client is an internal user. In this case, anynode will use the internal network for the ICE Lite negotiation and make the shortest path available. But obviously that is only a really simple scenario, and the local media optimization is only coming to its full potential when you're having more complex scenarios like the one shown right now, where you have at least two geographically separate locations. And in this scenario, we have just taken our scenario as an example, where you have the main SBC, the so-called proxy SBC in the terminology of Microsoft, which is connected to the Microsoft Cloud, and it's also connected to the local voice over IP carrier. And then you have a second SBC, a side SBC that is located in the US. And in between those SBCs, there's a VPN tunnel communicating over a private network and allowing us to really control media flow like we want it. I mean, it's meant to be for the administrators of the Teams tenant to control the media flow in relation to their own network topology to make it as optimized as possible. And so depending on whether your Teams clients are external or they are internal, and sometimes internal in your organization to the one SBC or the network where the one SBC is located, or being local in the network of the secondary SBC, the side SBC, then the media flow takes a direct approach, and that has the ability to use technology like MPLS, for example, to have a really high quality connection between two geographical separate sites over a high quality of service VPN tunnel, and then route your media over that tunnel instead of going through general wide area network, the general internet, for example. So we can really custom tailor the media flows, what is the best thing in your network situation, I would say. Yeah, from the configuration side, probably everyone has done some SBC configuration in your Microsoft Teams tenant. And I will not go through the complete configuration for the setup because most of you will probably be more adept at that than I am, because I don't do that day by day, but most of you probably are. And that's why I'm only going to be talking about the specifics. You have to on the primary SBC, which is the proxy SBC in the Microsoft terminology. You of course have to activate the media bypass, and on top of that, for the local media optimization, you have the bypass mode, which can be always on, or which can be for local users only. The difference between those two modes is that the internal interface will only be available for all users if you specify the always, and if you specify that it's for local users only, then it's only going to be used for the Teams clients that are in the local network of that site SBC. And you can configure that by specifying the appropriate rules in the on your tenant, and Microsoft then will send meta information in the signaling channel, which will tell the SBC which SDP candidates to use for the actual establishment of the media connection, and therefore the media flow can be highly optimized. The PSTN gateway configuration actually needs to be done for each site SBC. Microsoft needs to know of their existence, even if the Microsoft Teams instance will only communicate directly with the proxy SBC. But to be able to apply those rules until the proxy SBC and beyond what media pathway shall be used, Microsoft needs to know all of the site SBCs as well, even though only the proxy SBC will actually be directly communicating with the Microsoft Teams Azure instance. So just a little configuration on the anynode side. In anynode, I'd say 99% of all configuration that is normally done by a user is done using wizards to make setup as easy as possible. Here we see the wizard to set up a connection to Teams direct routing, and on top you see the configuration that is I'd say the old configuration prior to local media optimization, and of course here's the ability to have the multi-tenant configuration, which is not part of this track, but I think we do have actually another track which is specifically about establishing multi-tenant configurations. Here we talk about the local media optimization, and actually that is a selection that needs to be made if you want to enable local media optimization on your anynode site. I mean, you just select this feature, and the difference from a normal Microsoft Teams setup is only that there's one additional option, and that's the internal network controller, which is not available when you have a standard connection like in the first selection above. And that internal network control is going to be used to do media exchange when within the local network. Here we see the initial configuration, which you do for the proxy SBC, and the normal standard Microsoft configurations things apply. I mean, you need to specify a certificate that is accepted by Microsoft, the Azure system, and you can just, most of the topics, you can just click them through because they take sensible default values. And last but not least, you click on the finish button, and then your actually done. That's the primary part of the configuration. If you've done so, then you will see an object tree of all the stuff that is created for you. And if you want to have a more complex configuration, I mean, I've shown the slide with a simple local media optimization configuration. With that done prior, with the wizard I've shown prior, then you're all done with configuration. If you want to have multiple site SBCs, then you would need to do a little bit more. Then you would obviously install an anynode on each of those sites and then create a connection between the proxy SBC, which is this one here, and add by pressing the button the site SBCs to this proxy SBC. And well, after you've done that, then you're all set, and your multi-site local media optimized Teams configuration can be used, and you should be good on the go. So actually, that was everything that needs to be done to set up the Teams local media optimization. And after you've done so, well, then you take the system into operation. And when you're in operation, you obviously like to monitor your voice over IP infrastructure in various ways. And anynode has the ability to help you with that. The simplest way is to go on the web interface where you have a clean and concise monitoring section, which shows a survey of all the relevant resources that you've just configured, which implement your communication flows. And on each of those entries, you can even click and get more detailed information. But of course, your administrators have better things to do than to go onto a web interface all the time to monitor your stuff. And so we've implemented things like SNMP and WMI to be able to fully automatically monitor your mission critical components in your voice over IP infrastructure. And yeah, there are various monitoring points that we make available and which can be used in your network monitoring software and added to that. On top of those standardized SNMP and WMI integration, we also have implemented various REST APIs to enable your system administrators to control additional aspects of your systems in a very customized way. Of course, things can go amiss, and that can happen. However good you have been planning your infrastructure, and so it's important to get fast insight into the issues at hand. And anynode provides you with some really powerful diagnostics to pinpoint those issues and yeah, give you a fast way to locate and resolve them. Anynode can log its internal state and all ongoing transactions into log files. We call them trace files. And we have included in the anynode our trace analyzer, which is this central tool to analyze those trace files and help you execute the diagnostic process. And it can show information at various depth levels. First, you get an overview of your current system infrastructure or the configuration of your system, and which already shows you some specific information about the system where the anynode is running on and what network ports are available and stuff like that. And then you always get a list of all currently running and all sessions or calls and all sessions that have started and stopped while you were running. You had activate the logging. And for each call, you can go into the into the signaling view, and you see the signaling that takes place between the Teams direct routing on the one side and the anynode in the middle, and on the voice over IP provider for the other side, which might be several different ones, for example, or it might be some additional devices that you have added, and you will see a very graphical overview of what was happening during a session. And you can even go into the details of the zip packets if you care to do so. And well, you can go even one step further, and you can go into the media view, where you can see each packet that has been a media packet that has been transferred. And this picture here is actually one step further into the detail. It can try to re-establish the audio flow, so you can see what data has been received and sent, and it will be superimposed by additional information like if DTMFs have been received, which are specific RTP type, and information like jitter and packet loss and stuff like that, and that will be superimposed in the graphics. And here, for example, you can see the early media phase, and you see a point at which the call was actually connected through. So you know, okay, the actual audio conversation took place between this point and the end here. And like this little dot, there's more information like DTMFs and packet loss and stuff like that. So you get a real deep insight about what was going on during your media exchange phase. On the left side, you can even see that the communication that took place was using SRTP for encrypted transmission to make sure, okay, all our communication, at least on the one side, is encrypted and secure. And so it's a real good overview, and it's a real essential tool to allow fast diagnostic of potential issues. It will help your operational specialists to analyze problems locally and very fast, and in case your knowledge of the protocols involved has reached its limit, those exact same trace files will help our component support team to follow up and give you a helping hand. And then you can even delve further. It has even more depth, but that's probably something that's more for our support specialists than for your use case. But it's all the same tool that's being used by you guys in the field and by our guys in the support team, and even up to development, which are using the same tools to diagnose problems. Well, I'm close to the end already. We do have quite a few resources to enable our partners and customers to help them out and with our product, and give them more information and stuff to work in the field. And first of all, that's our support team. Actually, we can contact it either by phone or by email. Our team is really motivated in helping you circumvent any hurdles that might come up during planning, proof of concept, deployment, or operation. Just give them a call or send them an email, and they will be really helpful. Then central to everything is our TE Systems homepage with its download section. In that download section, you can download the current versions of our software, a huge amount of technical documents explaining usage and configuration of anynode in various scenarios, either be it with different PBX systems or voice over IP carriers, or other scenarios which are not 100% voice over IP related. And for partners and customers, the website can even be used to order licenses on demand. You should also take a look at our YouTube channel, because it really contains a large amount of tutorial videos which is constantly expanded to include the latest information. Actually, I think we're close to releasing a video about exact the topic of today, about the local media optimization, where configuration is even shown in more depth than I've done so today. And well, those YouTube videos help you in various situations on how to configure and deploy anynode together with your voice over IP infrastructure. Also, a good thing is our anynode Academy, which provides various training sessions, either as in-person or remote or even on-site variations. So take a look at those offered training sessions because they are really in-depth and help you get going for more complex scenarios. Yeah, I mean, like probably everyone else, we are informing interested parties about new features and tips and tricks using social media like Twitter or LinkedIn. And yeah, whatever way you want, please do not hesitate to contact us and get back to us with questions you got. And yeah, just tell us and we will be helping you. So last but not least, just a really short summary. Anynode is Microsoft Teams certified to make really sure that you have optimal interoperability between your voice over IP infrastructure and Microsoft Teams direct routing. And Microsoft Direct Routing provides 3 different media models. The latest local media optimization is by far the most powerful. This model will probably be the choice for all but the most basic scenarios. In this model, anynode can act both as a proxy and the site SBC. And for very small deployments, both roles can be even achieved in one anynode instance. I've shown the wizard. Anynode is really easy to use. Like I said, 99% of all tasks will be done using a wizard. But if you want to deep dive, you can do so as well. If you want to have really fine-grained control, it's possible as well. But like I said, 99% of the people won't need to use that. Yeah, to help with the operation of anynode, we have really powerful monitoring and diagnostic tools. And yeah, in case of hiccups, they will help you to analyze the cause and quickly resolve them. And yeah, so I'm actually at the end of my track on local media optimization. It's kind of strange talking just to a screen, not seeing the people. I hope everything was okay. It was the first time for me to do that in a scenario like this. And I would really like to thank you for your attention. And I would also like to really thank the organizers of the Comsverse for the huge effort they have taken to make this event happen. Normally, 1 month ago, we would all have met in London, but that wasn't possible, unfortunately. And I would also like to thank Stephen for being the producer of this session. And I think we will now start with the Q&A session. And if you have not done so yet, please post your questions so we can address them. Thanks a lot.
Thanks, Tobias. We don't have any questions just yet, but they could be quite lengthy ones, so we'll give people a little while to kind of finish typing. In the meantime, I've got a question, which you talked earlier on about the option in your SBC to choose whether you only accept bypass from local clients. What are the sort of decision-making criteria about using that? So does it make more sense if you have remote clients for them to connect via Microsoft into the SBC and not bypass, or does it make more sense for them to connect directly? I guess in a typical installation where your device is probably hosted in Azure, how do you make that decision?
Well, the decision is actually made by Microsoft by configuration of the tenant. You tell the tenant for each site SBC if it will do local access when you say always, or if you only do local access when it's a Teams client within your local network. That's actually done in Microsoft, and Microsoft will forward that information to the proxy SBC, and it will forward that information to the site SBC, and then the site SBC will offer the appropriate SDP, that the session description protocol, which is actually doing the media handling. When Microsoft tells that it's a local internal user, then the anynode will present the SDP of the internal network connection. If not so, then it will go on the external side, but that's totally controlled by Microsoft and the configuration in the tenant. So all your policy is done at that place. It's not done in the anynode configuration.
And if the user is external, can you choose whether they do bypass or whether they go via Microsoft?
No, I mean, when you're using local media optimization, they will always try to media bypass, but possibly not in the shortest way. I mean, then it will go to the external port of the proxy SBC. So it bypasses Microsoft and goes directly to the proxy SBC on its external interface, for example. That will be the case for all entities that are external, because external Teams clients cannot see the internal network of the various sites. So there's no possibility unless they're connected via VPN or something like that. But normally all external Teams clients will connect to the public interface of the proxy SBC, because there is no other way to do so. It's only for the Teams clients that are located on premises, I'd say, where the location of the site SBC is. When the Teams client is in that same network location, then it will really take the real short path to the anynode of that site.
Okay, thank you. So we still haven't had any additional questions here. So what we'll do now is we'll close this session here. I'm just going to post into the Q&A a link. If anyone wants to join that session, which is a regular Teams meeting, you can have a direct conversation with Tobias and his colleagues. This is a complicated subject. It's probably quite hard to type into a little text box a detailed question about SBCs. So I would suggest people take the opportunity to go and do that. Yeah. So thank you all very much for your attention today, and I hope you enjoy the rest of Commerceverse.
Bye-bye.